All right. Okay. So thanks, Herman. Yeah. So time really goes fast. It's
Yeah. Yeah.
wow. It seems like I think we were having some interesting conversation, and I think David brought in his colleague, right, to
Yes,
discuss about. I recall that person was at the airport as well. Okay,
that's right. Yeah.
that was right. I think you recall that, right? I think there was this meeting, but wow, it's almost a year ago now.
Yeah. Uh,
All right, all right.
yeah.
So yeah,
We,
so I
yeah,
guess
we were
really.
no,
Um,
you go ahead.
no, no, I was just saying that it is really important. I think that we focus on the important things
Yes.
because this thing that calls time really goes by, regardless of what you do.
Yeah.
So, okay, all right. Okay,
Yeah,
so
we
so
were
yeah,
actually
yeah. Go ahead,
speaking
go ahead.
about it in our. We had a strategic meeting on Monday and Tuesday, and
Right, right, right. Okay,
I mean, part of the one of the goals of that meeting was basically just to get back on course, if you understand what I mean. I mean, we had to do a lot of things last year just to kind of adjust and make certain that the things that we normally do on autopilot basically just continues working, kind of. And I think part of this year is basically saying, okay, how do we let's get back on track. But basically, what were we busy doing with again? Oh, yes, we were doing that. Okay, how do we get back to that and make it, and continue with that, those things that we were busy with. But anyway, so that's why I'm kind of interested to hear what Tom David they've been
right, right.
doing for the
What
past
would have been working, and especially
couple of months. Yeah.
Actually, I'm curious too, because he mentioned about they have been actually up the effort and got more people.
Yes. Yeah.
Yeah, it's in this day of age, if you actually get more people, you are really onto something.
Yeah. Yeah, that's
Yes.
true.
Yeah, because I'm pretty sure a lot of sectors things have been cut or reduced, or
Yes.
scaled back.
Yeah. Yeah.
Yeah,
Yeah. Ah,
yeah. But if you actually get pump up, then it's definitely yeah. All right. So
yeah.
I think maybe we maybe some quick updates. Okay.
Yes.
So yeah. So anything on your side that you like to maybe also think a bit?
Well, I mean, except for I mean, the progress with Victory, and
Right. Right.
that. Well, I think he's now. I mean, I think he's very close actually to getting a something that will, sorting out that detail of how this spatial routing will actually work, which I think is good. I think
Okay.
uh, he's read enough around it. Now he's busy with, okay, but how do you actually do it? Which I think is a key component of that.
Right. Right.
And I think that's good. Um, so I have spoken to Gert-Jan. We haven't linked again. I must actually send him a message saying we should speak about the agri stuff again. Um, I know he received some funding for he had a funding application. I know he didn't receive all the money they wanted for, but they did receive some funding. So they should be able to kick off with some kind of a project. But that's the other thing. I think we should pick up, or I should pick up that discussion with Agri-T again and see if we can have some kind of a workshop with the rest of the people in the agri-science department, and just make certain that that conversation doesn't just disappear. Um, but
Okay.
yeah,
Okay. Okay. All right. So that's on your side, right? And is
yeah.
there, I mean, regarding with GJ, I mean, is there plans for a follow-up discussion and
Well,
also on agri-tech?
that's why
Uh,
I'm messaging him now saying, hey, we should talk again and organize something with the agritech. I mean, they spoke about a workshop last year where we should have people together speaking about, what was his name? Albert spoke about that. So I just want to pick up those threads again. Everyone has gone on holiday now and has come back, and people forget what they spoke about last year. So just want to pick up those threads again and make certain we get that conversation started.
okay.
That
Okay.
conversation started again. Yeah.
Okay. All right. Okay.
Um.
Oh,
Here's
okay.
David.
I think David's there, right? Hello. Hi. Hi, David.
Hey, I'm so sorry I'm late. I'm really sorry. I just totally lost track of time.
Okay. All right. But thanks for joining. I mean, I know it's and late, right? It's
Yeah,
9
I
9
totally
p.m.
I
at your
was
place. Yeah, yeah.
yeah,
So
so happy New
no
Year.
worries. Yeah,
Good
no
to
worries.
see you.
Yeah, good to see you. Herman and I, we were actually just chatting about, like when was our last conversation, and we found out it was last March. Okay.
Wow, really?
Yes. I'm pretty sure you also didn't realize. All right.
Did not.
So yeah, time flies, and I think we should make the best use of it. All right. And apologies,
sure.
I have to leave. I think at in 20 minutes. Okay, that's
Okay.
I do have other other commitments, but
Okay.
I would just like to really quickly like maybe do a catch up with you guys, and I think you guys can continue to discuss. Okay, for maybe another half an hour. Okay, that's
Okay.
yeah, in terms of, because one of the things that just upfront is that Herman right now, in terms of research and student direction, we would like to get more motivation from students. And one of the idea that came up was to have someone from the industry to really speak about the importance, of spatial computing, communication, and all that, right? So sort of let them understand, because people are now onto AI and like all things related. Yeah. So
If it's not AI, it's not interesting. Yeah, basically.
Right. So basically, I mean, that's one thing to let you know, that maybe you guys can discuss about what, if that's possible, to invite you as
That would be
a
great.
speaker,
Yeah.
to talk to students essentially, but also have it recorded. Okay. So I think it would be nice as also sort of a to let people know about what Versus is doing. Okay. In that case, is someone joining me? Okay.
No, I think it's just David on a different device.
Okay. All right. Okay. All right. So that being said, yeah, we would love to hear your updates. Okay. And okay.
Well, I appreciate that so much. Yeah. So I guess there are a few updates. As you know, we have sort of two sides to the business. One, the commercial side, the other, the research standards, kind of nonprofit, open source side. One is the Spatial Web Foundation, the other is Versus Labs. And what's nice about this structure is that, sort of when you have nonprofits working with other nonprofits and standards bodies, you can have sort of the same orientation. But it's also, it allows us to interact with different research institutions in a way that I think we've come up with a fairly novel way, and this is relevant to this conversation, of sort of interfacing between academic and commercial interests. So on the commercial side, our production rollout in our first customer is going really, really well, and it's accelerating. So we're now into starting into the third warehouse of our vision picking, augmented reality, AI-driven workflow engine, which is going really well. And we also have a really cool project that I think is probably quite relevant to any work we've spoken about and might do, which is a project with the European Commission to help design the drone infrastructure for the EU, along with Microsoft and a number of other partners. And it's a really interesting project. It's a 3-year R&D project. As you can imagine, there's lots of spatial networking and agent-based modeling type of all kinds of very, very relevant aspects to it in terms of emergency messaging and efficient, redundant, provably redundant messaging pathways and communication pathways. There are all kinds of interesting things, but it consists of 5 living labs, which are cities in Europe. And each city has a little bit of a different focus, but overarching goal is the same, which is to build a trustable, reliable, AI-driven drone infrastructure. So, really cool project. I can tell you more about that. So that it's definitely quite relevant, but also, you know, one of the things that we've been doing, which is, you know, part of what helped us get this award, is that we've taken a very different approach to AI, and we took a sort of starting point where we said we're going to create a real-time digital twin and real-time model of the world, multi-dimensional model of the world, and we're going to use base reality as our consensus algorithm. And we're going to start enriching context around space-time, individual three-dimensional points and ranges of points and locations and time. And we're going to enrich, you know, those locations with context, whether it's multi-dimensional context, which is sensory apparatus. What's the temperature? What's the air particulate? What's the density? What's the, but then also social layers. Who's the owner? What's the policy related to this? What are the credentials and certificates that are required for this? You can basically program space and program context. You can simulate a future context and take in the same layer that you do data analysis and retroactive interrogation and introspection into the transaction stream of the digital twin itself. So you can go from a simulated state, from the digital to the physical, and get that cybernetic loop really accelerated. So we've done really well in these warehouses and this drone program. And so the research is with this AI technique called active inference. And it's based on the work of a neuroscientist named Dr. Carl Friston. I don't know if you know of his work.
No.
Shunyan, do you know of Carl Friston? Do you know of him, Shunyan?
No. The name doesn't. No. Not.
So yeah.
No.
So he's a neuroscientist at the University College of London. Our director of AI, I guess, Dr. Carl Friston was the PhD advisor for our director of AI. So it's basically, he's a neuroscientist. I think he's got more citations than any other researcher. He's got like 250,000 academic citations.
Okay,
Wow.
alive, right?
Yeah.
That's a lot.
I have 0, so I don't know what 250,000 means. It sounds like a lot.
It's a lot. It's a lot.
That's respectable, yeah.
So he's joined as our chief scientist for the Spatial Web Foundation, which is really exciting because a lot of his work is in neuroscience, and I guess he invented the mathematics of the brain, and basically what allows us to do MRI type imaging and stuff like that. And so if you think about a lot of what we're trying to do with computational systems, is we're trying to mimic the best things we know, you know, with respect to communication systems and, you know, computation systems and things of that. And of course, you know, the human body to us is incomparable. We cannot imagine something beyond which, you know, that which gives us that imagination, right? You know, to that point. I think we can exceed the brain. We probably won't know if we did, but the brain can't understand, you know, a lot of what, you know, intrinsically won't be able to understand, you know, the singularity any more than, you know, an ant understands, you know, the human, you know, perspective. So, you know, we're getting into this sort of biomimetic, you know, type of structure. So, active inference kind of, I kind of describe it like, if you think of neural nets right now, it's sort of like you've got these black boxes where you're training, you know, AI models with data sets, right? You're putting these things, and they're these kind of black boxes, right? They have no dimensionality to them.
Yeah.
So what we do is we say, okay, well, we want the AIs to operate on our digital twin of reality, right? And so what we want to do is we want to allow the AIs to do what we do, but in the dimensions especially that we don't have access to, and looking across dimensions, you know, faster than we can. And so think about the way that, you know, human cognition works. We bring in multiple sensory inputs from, you know, our different senses: smell, sound, taste, touch. And so if I see smoke coming out of my kitchen, I'm gonna sense also the density. I'm gonna sense the rate of speed of movement, how quickly it's, you know, so I'm gonna actually factor all that in. Then if I happen to smell it, I'm gonna do a fuzzy, you know, kind of logic query into my brain for experiential inference at what the heck is going on here. And I query, I'm like, does that smell like a toast burning? Does that smell like this? And ultimately what happens is we get these inferences, these recommendations or ideations of what the possible situation is, combined with the possible recommended action or set of actions to take. And that, yeah.
I mean, that sounds very much like some of the reinforcement learning type of, I mean, the whole, you know, you have your environment, your sensing, and then you have to decide what your next action is based on it. I saw there was a tutorial on this active learning, and one of the, in the, what do you call it? In the abstract, they already talk about something called the partially observable Markov decision process. And the thing which is interesting to me about that is that, I mean, that's basically one of the basic building blocks of reinforcement learning, which is the other big thing in AI at the moment with the work of David Silver and then AlphaZero and all those kind of things. So what's interesting to me is this link between, I mean, what you're talking about in terms of the active learning and what you're doing, and there's these links to what's current state of the art in machine learning at the moment, which is
and I think it's sort of, I think, the land of and. I mean, I'm not trying to say this is like, you know, any potentially more significant or not more significant.
No.
I think it's a very exciting area of new evaluation, and you're right. I mean, it does actually use techniques, and it supposes techniques of sort of Gaussian type, you know, reinforcement learning and things, you know, generative adversarial networks, all those are types of techniques. I guess it's sort of like the brain has all of these like very special purpose, you know, kind of chips, you know, if you can imagine, like we've got, you know, our, you know, whatever it is, like I'm not actually a brain scientist. I know not, but the basal ganglia or whatever does Bayesian, you know, types of learning, like that is a special purpose hardware to do that type of, you know, cross-dimensional, you know, type of, or sort of, you know, Markov blanket type determination in across categories. Like we intuitively understand that when we handle an object, whether it's a football or a baseball, you know, there's some different.
Hi, sorry guys. Yeah, I think it's too hot. My phone shut down, so I better turn the video off. Okay, for now.
Okay.
Right. Go ahead.
Yeah. So, you know, we intuitively understand that there's some commonality, some substrate of interaction where we understand there's dexterity around movable objects in physical space. We understand wind as a general property, right? And we also understand how wind interacts with a football versus a Frisbee, depending on how much experience we have and how much we've interacted in that, you know, sort of space of exploration. We'll be able better, someone who's thrown a lot of Frisbees or a lot of footballs can, and just gauge, you know, might need a couple calibration throws into the wind. From there forward will be 99% more accurate, or even almost, you know, much more percent accurate than somebody that's never thrown a football ever in any wind, right? So that that happens, but we also understand there's something connected between throwing a baseball and a football and a frisbee across categories. And there's something to understanding standing in the wind and feeling the wind blowing at you at 100 miles an hour, and how that impacts your understanding of wind and the properties of the windness of wind. So there is this like general sort of, really kind of, I'm not saying it's meta, I'm not quite really sure totally how to describe it, but it's a very meta level, understanding of how these subsystems work together.
Okay.
In fact, yeah, so
Great.
those are the
All right.
research areas, I guess, more so.
Okay, yeah. So let me see if I understand correctly. You're talking about the next generation of AI, essentially, which is the current generation. I think it's really just mappers. They sort of map certain data sets to some input to some outputs and do it fantastically. Okay, they are basically great
exactly.
pattern recognizers, so to speak.
That's exact pattern recognition.
But there's no comprehension, right? There's
Correct.
no comprehension that's in any way that could be called intelligent or related to intelligence in that sense.
That's exactly right.
But I think what you're describing is a move towards comprehension, right? At the I don't know.
It is, because there's also, it turns out that, I think we sort of agree internally that spatial representation and interaction predates language and tooling, to some extent. Spatial experience is actually a precursor even to language itself. We experience the shape of something before we need to give it a name or to describe its action and interaction.
So, quick question. So Versus and Versus Labs and the Spatial Web Foundation. So it sounds to me like you are actually working on two aspects. One is just building the infrastructure in order to get the data from this, which is spatially, to the agent or whatever it is that's making the reasoning, and then you've got this digital twin which is syncing with the real world, and then once you've got the digital twin in the middle over here, then you've got your interesting AI working on it. And I guess the advantage of doing that also is that you've got this slight decoupling, that the AI doesn't really have to worry about the interfacing with the real world because it's just working with the digital twin. Okay.
Yeah. The data format itself is sort of modeled after, sort of our base understanding of reality. Like, there are 3 dimensions, and then there's time, which is movement over time. And that's how we experience. But then we sense other dimensions like acceleration and, density and, chemical composition. All of those are other dimensions of something that happens at a point over time.
And that's what you're calling, that's the context and the enrichment that you're basically adding to the...
Exactly. Okay. The context is what's happening. Like, we're running as, probably mathematically irreducible multidimensional simulations on some sort of primordial space-time, space soup, right? And we represent matter-based simulations of computationally irreducible simulations. That this needs to be instantiated in hardware. We are the hardware of some, multi-dimensional simulation that happens, I don't know if that's, not to get philosophical, but in terms of where we are as a, entity, we've got like very practical, we're now rolling out and doing warehouse optimizations in pick and pack facilities. We are talking to CIOs of multi-billion-dollar, lots and lots of CIOs of multi-billion-dollar enterprises. We are working on the research side, accelerating, hiring researchers on retainer, contract project basis. I'm not so sure of how all the money works, but on our research side at the Spatial Web Foundation, we're, contributing to research, investing in research, but really trying to do so in a very transparent way where we recognize the commercialization has to do with bringing things into the world, which is necessarily messy, you do want to have a much faster cybernetic loop between what happens in the research dimension and what happens in the real world. And how do we get that happening as fast and quickly as possible without, very substantial, risk at the end of the day.
Okay. Okay, but one of the things what's really nice, what's for me now, which comes out of this, is there's actually a very, very nice connection between the AI and the machine learning and the spatial web application. Because what I found is whenever I start speaking about students and I'm like, okay, but we're talking about spatial routing, and they're like, yeah, that doesn't really sound very exciting. But you basically now, made very clear to me is like, you can't talk about all this machine learning and all this fancy stuff you do and doing it in real time if you don't have this infrastructure, which is basically bringing you.
You cannot ignore spatial. It's entirely impossible, right? And what we need is the bridging and the connection between the semantic, the spatial, and the social, right? Like I should be able to ask the network, Jarvis, up there in the sky, Siri, Alexa, whatever your name is these days, like where does this activity happen, right? Or like by some motion of shape, you could ask me, hey, can I come over and borrow the salt? Hey, sure, not a problem. That would ambiently deploy a rule into the security system, and all the compounded related security systems that could be chained together as thresholds of trust, right? You could present your credential even to get to this point as far out as you want it, and the intentionality behind that. And when you show up at my door, it'll have tagged this exact interactive moment where I was like, sure, not a problem. I happen to step out, but my security system knows to let you in, and you have augmented reality instructions on exactly how to get to the salt. Now we need to decide as a society, do we need the computational overhead of also having something that detects, did you only take the salt out? Right? Like, did you also take my bike while you were there? Well, we need to decide if we can't trust that someone we decided to bring into our house, they might, come in for the salt. If it gets to the point where you're loaning them your salt and they live close to you and nearby as a neighborhood, if you're that off, well, we've probably missed some other things too, along the way.
Yeah. All right. So thanks, David. Yeah. So sorry, I have to break you. So just, I guess, very quickly. So are there specific things right now you're looking for to to help in your efforts? I guess either in terms of expertise or resources to sort of complement. Yeah.
Definitely. I would potentially love to really see if there's some thesis about the interconnection between messaging, and routing in a spatial context, like channels, basically, and also, agent-based modeling. So understanding certain agent-based conditions and communications. So in our drone project, so for example, you might imagine a scenario where a bunch of drones might be flying at a certain point where they have the ability, because there are 4 of them in a certain proximity, to take a certain type of environmental sensory snapshot at that exact moment, like CO2 or a lot of different types of things, air particulate, or other different types of things that could be sensed. They might only be effective and effectual if 4 of them take it at this exact type of geopositional perspective. So what happens is, as you kind of plan your flight, as these things start, they now sort of self-organize, and we now realize, oh, we can actually now communicate with one another in an efficient enough way in that sort of local area network of that specific context to now negotiate the level of credential proof that is cryptographically understood to be necessary from a security standpoint, because that has everything to do with how much, you know, cryptographic computation absolutely has to happen at the edge, you know, from a you know, just overall security standpoint. So, you know, to summarize, we're looking at a lot of, you know, agent-based modeling and messaging mesh architectures, and, you know, having, you know, sort of being, you know, whether it might use some, you know, core I guess algorithms and or libraries and or, you know, APIs, SDKs, whatever that you've already
Okay, I see. Okay, all right.
already built, or we can just sort of, you know, treat it as there might be just, you know, great potential to work on new projects, and we could sponsor future research, kind of slightly directed research, right? Where we say we don't really know we know that we learned from this last thing that the most important area is to understand how we can do, I don't know, a certain type of tunneling. I mean, I'm just I have no idea what I'm talking about, but
Okay, all right. Thanks, David. So I
but
think
yeah.
Herman can.
On that note,
Yeah, all
I
right.
have no idea what I'm talking about. And on that note, that's no. I think you see what I mean. Where we try to the interaction to me is like completely plainly obvious between messaging, message routing, for events, system events, you know, content. It's all the same thing. It has to do with prioritization of pathways. You know, how do you handle different notification levels and thresholds relative to the bandwidth that's available, whether it's cognitive bandwidth or, you know, physical bandwidth. That's what it amounts to. So
Okay, all right. So I think Herman can update you with what we've been doing here related to that. Okay, because right now there's a PhD student that's actually designing sort of how we can make a decentralized version of spatial PubSub. Okay,
that's
spatial puppet.
exactly what
Right.
we need. That's basically
Right,
what
right.
we need. Right.
So I think there are rooms for that. Yeah, and
Okay.
I do have a couple of things to share. Okay, to just for you to maybe to see if it could be relevant or useful for you. One is I have come into contact with this professor, actually a contact of mine years back. I sent that in the linking. Is Professor Jia Jingyuan. Okay, he actually took his PhD in Hong Kong. Okay, so also okay, I mean fluent in English, and he's been doing some pretty neat, I think, efforts in terms of making spatial web applications commonly usable, adoptable by the mainstream. Okay, in terms of lightweight modeling and meshes, textures, and all that. Okay, and even to the browser engine. Okay, so that like this 3D model that was like 2 GB in size, a building model, you can just stream that within a minute. Okay, and it's
Wow.
displayable on the browser. Okay.
So I clicked on those two links and I couldn't get to them. I don't know if it was, you know,
Oh,
one
okay.
not in
So
English, the other,
Prob-
you know, didn't load. for some
right.
reason.
Okay. So all right. I think. All right. So that is something I think. When okay. I
But
don't know
it
if it could
seemed
be the
like
bandwidth.
I mean, I get that it seemed extremely relevant. I didn't, you know, partially now that we have more people that are more purely on the research, and we're now being able to kind of identify what those boundaries are of like how it would be best to engage, you know, in one type of project or another.
Right.
One, we have, you know, we have sort of commercial stuff. We know what's immediately applicable, but we also now have like pretty, you know, pure research going on. So we now understand a little bit better, you know, how to approach one or the other. And we have more resources, and things like that. So, you know, like that was partially what was challenging before was we didn't have as many options in terms of how we could
Okay.
approach that's all. Now we can approach things in, I think, a lot more of a flexible way.
Okay. Okay. Nice. Okay. So the other thing I'd like to share is this other link. I just shared the linking as well. It's called Lucy, okay? And Lucy, that's like the original human being in Africa. That's how they
Yeah.
name after the company.
Yeah.
And what they have done at the core is AR technologies, okay? But this is a Taiwanese company for 10 years now. And I would say they have one of the, more mature solution in terms of applying this for actual building safety, okay? So the use case is that with the AR goggle, you can going around a building and you can just see where the tubes, like the fire hoses and also the internal tubes lie within the building's interior, okay? So this may be useful for like safety inspections, okay? So, and they are having this use cases and also trying to build up targeting at some of these, top companies in Taiwan to provide such solutions for them. And I think one of the things is that this is indeed, like spatial applications, okay, and also have a very direct use case. So this is, another company I came into contact with that I think that might be related to what you guys are doing. Okay, but I just kind of like to know your feedback on whether any of these would is of interest, to explore further. Hello.
So I mean, I
Yep.
saw this Yuku 3D.
Oh, sorry about that. I was on mute. Yeah, that makes wonderful sense. And this is really, very aligned.
Okay. Okay. All right. So I guess the immediate thing that could happen is I guess to invite David to her perhaps to have a seminar, or maybe one of your colleagues. Is that something you think that could be doable? And
Yeah,
obviously,
I think
the
it's
other
doable.
thing is to see how the efforts are. I mean, Herman, student and our PhD student can potentially help in what you guys what Versus is doing now, and maybe as a use case. Okay, so I think that's the direction.
Yeah. Yeah. I think that that is the direction. So I actually have another a call, unfortunately.
Okay.
But this is really wonderful. And yeah, I'm really excited to reconnect.
Okay. So yeah. So all right. Just quickly. So is that something you think you can do, or you are able to maybe have a seminar and to the students here?
Yeah,
mean,
yeah,
so-
I'm certainly very, I'm also, I think I would like to bring my colleague, the director of AI, because he also has an academic, he's knows a lot about AI. So if I'm talking about it,
Mhm.
he also understands what we're doing in spatial and can explain like the maths and computations.
Oh, okay. I see. Okay.
If anybody asks, but yeah, I think that would be great. So if you send me, info about it, I'm sure I can get him in on it.
Okay. Okay. All right. So Herman, what do you think?
Yeah, I think that's a great idea. Yeah, I've already gotten we've got a what we call a machine learning forum at our university, which is quite active, which I think and they
Okay.
have these bi-weekly or twice. They have meetings every 2 weeks where they have seminars, and I think that would also be a good platform for doing something like this, because there's a lot of, there's quite a number of people that actually come there. So I think that's a way of also connecting to the AI people in our area, and basically bringing the importance of the spatial web there as well.
Okay.
But
all
I
right.
can send. I'll speak to the guy who organizes that at our in our area, and then I'll send that information through to David.
All right.
That
Okay.
would be
Great.
wonderful.
So
All right,
yeah.
well-
So I don't want to keep you too long, but great thanks, David.
I really
Okay.
appreciate it. It's so good to
It's,
connect. I'm really excited
yes.
to follow up more. Okay.
Okay. All
Cool.
right.
Thank
So
you.
Thanks. Yeah. Thanks, David and
Bye.
Harvey. Yeah. Bye bye. Yeah. Bye bye.
Yep. Take care.